Hey friends, Vincent here. Welcome to Fearless in Rust, where we keep Rust clean and simple. Let's get into it. Today, we are continuing the Hexagonal Architecture series, and we are moving one ring out from the domain into the application layer, also called the use case layer. That you can see right here in blue and yellow ports. Last time we stayed right in the center and looked at the domain type telemetry. That file is just business language. IDs, timestamps, metrics, no HTTP, no files, no database, no Hexum. Now the question is, how do we actually do things with that domain model? How do we implement fetch telemetry or ingest telemetry without letting HTTP or storage leak into the core? That's exactly what the application layer is for. In hexagonal terms, the application layer is where we orchestrate domain logic to fulfill a user goal, and define input ports, how the outside world invokes a use case, define also output ports, what the use case needs from infrastructure, and coordinate flow, validate, enforce rules, and call the right domain operations. And the constraint is the whole point. The application layers know nothing about HTTP, CLI, database, file, queues, or frameworks. It depends only on the domain and on port traits. Alright, well, let's walk the RustPulse code and make that real. So, first, telemetry file. Yes, so first, we focus on telemetry use cases under the telemetry folder. This is still inside the hexagon. It's core code. Now, I like starting with the public front door of the module. You'll see it re-exports the pieces we want overlayers to use. Telemetry ingest case, telemetry query case, telemetry repository, and telemetry service. This is a small design trick, but it's powerful. Adapters, that we will explain in the next video, don't need to know your folder structure. They can just import telemetry query case and stay decoupled from internal module layout. That's a clean boundary. Okay, now about input ports, how the world calls us. So the file query use case. So in hexagonal architecture, input ports are what the application can do. In Rust, that's naturally a trait. So this is the query use case interface. It takes a simple optional input if you want to filter on a specific node ID, and it returns domain object within a vector of telemetry. So here, no Hexum types, no HTTP request struct, no SQL rows. Just the language of the core as give me telemetry. Also notice the tray bounds with send plus sync. That's not business logic, that's a practical constraint because we want to share it safely across async tasks in the web server. Now, the ingest use case. So here, this is the command side. Same ID. Domain in, success and failure out, no transport details. So at this point, we have two input ports. One query, fetch telemetry, and one command, ingest telemetry. That's already a nice CQRS shape. And by the way, CQRS stands for Command Query Responsibility Segregation. This is a pattern where you separate write operations that change state from read operations that fetch data, allowing each side to scale, optimize, and evolve independently. And because there are traits, a CLI adapter could call this, an HTTP adapter could call this, and also a gRPC adapter could call this, without changing the core. Now the output ports, so what the use case need. So let's go to the repository file. So now, use case usually need to talk to the outside world, but the application layer can't depend on a JSON file or Postgre. So what we are going to do? We flip the dependency. We define an output port as a trait. That's here the repository port with save and query all. This is the key hexagonal move. The application layer says, I need something that can save and query telemetry. It does not say open a file or run SQL. The infrastructure will adapt to this trait later. Now about the use case. So let's go to the telemetry service file. This is, okay, right here. This is your application service, telemetry service. That single line is the dependency rule in code. The use case depends on the output port, so telemetry repository, not on the adapter implementation, that we will see later. Telemetry service is our use case engine. Notice it holds repo ARC for atomic reference counter, DIN telemetry repository plus send plus sync. This is an output port, meaning the use case needs a persistence capability, but it refuses to know whether that's JSON-L, Postgre, or a mock. DIN makes it any adapter that implements the port. ARC lets Axum share it across requests safely, and send plus sync makes it legal to share in async. So, now about the new part, the constructor part. Here, this is a classic dependency injection. You pass in something that implements the output port. The core doesn't build adapters. Infrastructure will create the real repo and pass it in. That keeps the dependency direction correct. Core depends on traits, and edges implements trait. Now about the block part, right here. Now the service implements the input ports, telemetry query case and telemetry ingest case. These traits are the buttons the outside world can press. When the HTTP handler calls fetch all or ingest, it's really calling the input port, and the service orchestrates the flow by delegating to its output port repo. And here I just let some comments that was enabled to me to understand more this part of the hexagonal architecture. So I let you for you guys, hoping it can help you also. Okay, now the composition route, where everything gets wired. So let's go to the infra part with the startup RS file. So here, this is the one place where we allow to connect the dots. First, we build the output adapter called repo on line 21. Then we build the application service and name services on 22. And after we inject it into the HTTP routes. This wiring is outside the core, and that's exactly where it belongs. So the dependency direction stays clean. Domains depends on nobody, application depends on domain plus ports, and adapters depend on ports. Finally, the infra right here with the startup file will wire everything together. Okay, so now let's wrap up. The application layer is the traffic controller of your business system. It defines the use cases as input ports and defines also what it needs via output ports. And finally, it coordinates domain objects to achieve the user goal. So in RustPulse, you can see that clearly input ports, like telemetry query use case and telemetry ingest use case, output port with telemetry repository, use case implementation with telemetry service, HTTP adapter calling the port, output adapter implementing the port, and everything is wired all in one in the infra space. So, next episode, we can go further into handlers and adapters. Thanks for your time. See you there.